Hi, my name is Dan Grissom. Thanks for checking out the UCR Digital Microfluidic Biochip Static Synthesis Simulator. So in this tutorial video, I'm basically going to show you how to create your own scheduler, placer, or router. And so by that, I'm going to really show you where you need to make modifications to the code to insert your own implementations, as well as where just a few pointers about things you're going to need to change. So let's go ahead and get started here. Open up our clips editor, and let's go ahead and open up just the main.cc file. Okay, so in here, let's take a look. And we have our three functions here: scheduling, placement, and routing. So I'll first start off by just adding a scheduler. And the process of adding a scheduler, placer, and router is pretty much the same for all three. But I'll do a scheduler and a router in this tutorial. So the first thing you need to do is, if you watch some of the other videos, you know that we passed in a scheduler type or a placer type or a router type to each of these functions. So the first thing you need to do is make a new type. So if you hold down, let's go back. If we hold down and click on this, it'll open up the enums.h file. And you can see here we have our different types: scheduler, placer, and router. And you can see at the very end even it has a place to show you that you can add a new type here. So let's go ahead and add a new scheduling type, and we'll do a routing type over here as well. So we'll just call this my_scheduler, and then for the router we'll make a new one, and we'll just call it my_router. So just try and keep with the convention here. It's the cleanest thing. We'll keep the scheduler and routers end with an S, the placers end with a P, routers end with an _R. So now that we have those in there, there's two places that we need to modify next. So if we go into schedule, we'll see that in this big if else statement, we're actually specifying, this is where we specify which actual scheduler is selected. So come down here and we can just copy and paste this line of code. So now it's new scheduler. So what I'll do is I'll say my scheduler instead. So you see it recognizes that now. And then we'll give it my scheduler, which doesn't exist now, but we'll create that in a second. So go ahead and copy that. There's one more place you need to make that change. And that is in, if you remember, the other place we might call that is in the entire flow function, right? So if we go into entire flow, and then in the where we actually create the synthesis object, which it's in the same file as that last function we just modified, you'll see here also we need to add an option to create my scheduler. So let's do the same thing with the router. While we're at it, while we're in this function synthesis, just scroll down to the router and let's add a case here. So else if my router, you'll see it'll recognize that, then my router. And then finally let's skip down till we get to place the route function, and we'll do the same thing. Copy this. My router. Okay, so finally we need to actually create the scheduler and router. So let's go ahead and close this, and we'll go ahead and save. Comment this out. We'll just look at the scheduler for now, so we'll just comment out these others. So go ahead and open up on let's just go to the headers first, and go to the schedulers, and go ahead and just right click, say new header file. We'll call it my_scheduler.h. And then let's go ahead to the source folder, to the scheduler folder, and we'll do the same thing here. Say new source file. We'll say my_scheduler.cc. Okay, so now we have our header and our source file. And the easiest thing to do here is to simply copy and paste from an already existent file. So let's go ahead up to scheduler, and we'll just, for instance, we'll grab a listscheduler.h. So you see here, the list scheduler has one important feature, or two important features, and one is that list scheduler inherits from scheduler. And if you watch the other videos, you notice that in the synthesis file, when we call schedule, for instance, we're always calling the same generic scheduler, which has a generic schedule function down here. And so we're essentially going to override that schedule function in our new scheduler. So you see list scheduler actually does the same thing. It overrides scheduler. If we look at the scheduler file, you'll see that it has a schedule function. Let's see, where is it? Right here. And if you actually look at it, it basically tells you no valid scheduler was selected. This needs to be overwritten. So we'll close that up. And so let's go ahead and just copy this whole list scheduler, and we'll just paste it in, and go back and basically change it. You know, we can say my scheduler. Maybe this was implemented from, maybe this was detailed in, you know, author, whatever you need to add there to change it. And then, of course, change the list. Everywhere you see list scheduler, change it to my scheduler. You may or may not need to inherit these things. But then obviously we need to change the class name to my scheduler everywhere it appears. And at the basic level, I'll just remove all the stuff that you don't need necessarily. You may need to say no. You'll definitely need to say no. But the main thing you're going to start off with is simply the schedule function. So let's go ahead and in scheduler CC, I'm going to go ahead and open up list scheduler CC. I'm just going to again copy and paste. So in my scheduler, just clear it out, and I'm just going to paste in the list scheduler to make it easy. And obviously, you know, you want to go ahead and change all the details to your appropriate scheduler, my underscore, so on and so forth. And let's go ahead and change everywhere we see list to my. And then we just deleted this function from the header, so we'll get rid of it. You may find that function useful, you may not. You can keep it, or you can redo it, or whatever you want. And lastly, we'll change it here. Okay, and so at this point, you're free to do whatever you want in the scheduler. I'm going to go ahead and just delete, since this is the list scheduling implementation. I'm going to go ahead and delete this. And I'm just going to put a C out. Scheduling via my scheduler. Okay. Okay, so let's go ahead and try to compile the scheduler and see if we can get it to work. And I'll show you in kind of the process some of the common small errors you might get. So let's go ahead and just compile. See the problems we get. So it's saying the architecture was not declared. So what I did in this last file, I removed the references. So let me go back to list scheduler, and I'm just going to include these references again because we do need to include the scheduler.h because we were inheriting it in our own header. So we do need to include that. So let's go ahead and build again. Okay, now it's complaining about the router and the scheduler. So since we're just looking at the scheduler right now, let's go ahead and just for the time being, I'm going to comment out the router declaration. So we do it once in synthesis, and then we do it again in router. So that will get rid of our router errors right there. And then we should get one more for scheduler. And so the last thing we really need to do is need to come into the synthesis header file, and at the very top we need to include the my scheduler that we just added. So let me just go ahead and add in my scheduler, and let me compile that. Okay, and now finally, if we run it now, it'll give us the list scheduler, so we need to make sure we come back into our schedule function and change it to my scheduler. So now when we hit play, you see we have scheduling via my scheduler. It shows you the lapse time and things like that. So you've just implemented your first scheduler, and obviously this scheduler isn't doing anything. So the interface file that's produced is going to be useless and garbage. It's not going to be able to be input by another placer. But the point is just showing you what things need to change to create a new scheduler. So let's go ahead and finish up the router really quickly as well. So let me open up my synthesis again, and I'll go ahead and uncomment out these things. And then let me go down to the very bottom for the router, and I'll add these. And let's go ahead right now in the synthesis header, and we'll go ahead and just add the include for the router. So we're going to call it my_router. And now let's go ahead and actually create those files. So let's go over to our router, say new header, so my_router.h, finish, and then router new source file, my_router.cc. Okay, so let's get rid of the schedulers. We're done with those now. We should be done with synthesis as well. Okay, so go ahead and just delete everything in there, in the header and the source file. Okay, now, so something to know about the routers are there's been a lot more research done on microfluidic routing. So with the schedulers, there's maybe a few schedulers out there. There's a genetic, some lists, and some various other ones. For placement, there's not a whole lot as well. But for routers, there's actually quite a few routing papers out there that exist. So I've implemented just a few basic routers. Some of them have just come up through our lab. Some we've implemented from other papers we've read. But there's different classes of routers. So just like the scheduler and the placer, you're inheriting from a basic router. So you can see here we have a router header file which doesn't inherit from anything. So if you're creating a router, you can inherit directly from the router file, just like we did with the new scheduler from the scheduler class. However, I've also implemented another class called post subproblem compaction router. So you see if we open up the header for that, it actually inherits directly from router. So this is just for a special type of routers that essentially, so what the title means is a subproblem for a routing subproblem is basically when a number of droplets are routed. So one class of routers, what it will do is it will create individual routes for droplets, and then after, so post subproblem, after it creates those individual routes, it'll actually run those routes through a compactor and actually cause the droplets to be able to move at the same time. So we've identified a number of routing algorithms that kind of follow this flow. So we've created a specific class that can be inherited. So you have to basically do less work re-implementing things that don't need to be re-implemented. So if we go ahead and look in this function, if we look at the route, again, this has a route function. So if you look in here, you'll see that it's a pretty simple. It's just a few lines of code here. And it has this main loop, and you can see every time it goes through this loop, it's routing a new subproblem. So maybe it's routing 4 droplets through this one loop, and then next time we hit it, it's going to route another few droplets based on just however many subproblems we have. And it basically, we have two steps. The first step is basically to compute the individual routes. So in this step, it computes a route for each droplet that needs to be routed in this subproblem. And it does that without really considering other droplets that may be moving around at the same time. So once those routes are computed, we run it through a compaction, which essentially takes those routes that were just computed and tries to make them occur at the same time. So all the routers that we've done have implemented and are releasing in this release actually follow this method. So we're going to show you basically how to create a new router that kind of follows that general method. So we'll just start off with this Roy router. This is based on a Roy maze router, and we've modified it, made some small modifications to it. But we'll show you how we can basically just start here. So let me open up royrouter.h and royrouter.cc. And you'll see, let's just copy and paste again into my router. Again, changing the key, my router, and then obviously changing the details here. We'll go ahead, my router, and we are inheriting from post subproblem compaction router. Let's go ahead and just make it my router. We won't need some of this stuff, but I'm going to leave it here just for simplicity's sake. Let's go ahead and rename everything that is a Roy router for now to my router. Okay. We can get rid of some of these as well. These are specific. But the main thing you'll need to inherit in this class is compute individual subproblem routes. So many different routers, they'll have a different way of computing those individual routes, but then they might send it to a similar compaction algorithm, or maybe there's a number of compaction algorithms that we can choose from. And you can see that when we go back to our main routing call, that we actually specify here which type of compaction algorithm we want to run. So right now I just have two simple ones. This one basically adds stalls at the beginning. This one adds stalls into the middle. You can implement your own compaction algorithms as well and add those to the simulator. So going back to the header file, sorry, the myrouter.header file. So we have this function right here, which will be overwritten, and we also have router-specific inits. And this is basically anything you want to call before you actually run the router. Maybe you're creating some kind of one-time map or something like that. You can do it in this function. So let's go ahead. We'll copy over the code from royrouter.cc into my router. And again, we'll just change everything here to my router. Oops. Copy paste. Destructor. Obviously we're not really using the same thing, so I'm just going to empty these out for now. Router specifics, you're going to do whatever you need in here. And then we'll delete some of these, and again, you may find these functions useful for yours, for your implementation, you may not. So the main thing is you're going to come in, and in this function, whatever particular way you want to compute the individual subproblems, in that basically computing a route for a droplet to get from a source to a destination, you'll do it right here. So you would come through, and right here this is using Sukup's maze routing algorithm. So I'll delete that, and then I'll just say cout routed via my router. Del. Okay, so let's go ahead and compile this. And it's giving us some errors here. My router does not name a type, so we forgot to change my router. Let's do this again. Okay, well, just forgot a few things here. compile. Yep, so you need to be careful, make sure you get all the headers, make sure you copy everything over right. It's a little sloppy. Okay, so everything's copied over correctly from Roy router to my router, and we'll go ahead and run it. And I'm going to show you what's going to happen if I just run route on this. Let's say that I just compile it with the normal Roy router, and we hit play. It's going to give you an error. It's going to say failed to properly read place because we don't have an actual placer output router input. So if we go into our folder, our C++ simulator folder, go to the output, you'll see that we don't have the file that we need for the router. So what I'm going to do is essentially I'm going to run the scheduler and the placer beforehand just to generate an output. Now I'm going to go back to a list scheduler just so we can get a valid output. So we'll do list scheduler, we'll do Grissom's fixed placer, and then for router, we'll do Roy router just to see that this is working properly. So let's go ahead and compile it, play it. So we see here it did scheduling, placement, and routing. Now let's go ahead finally and change Roy router to my router. Compile it, and we'll run it. And okay, and so we get this small error right here, invalid constructor used for router variant. So must use form that accepts DMFB architecture. So basically what we need to do here is go back to our synthesis, and what I'll realize is that when I created this, I forgot to add in the architecture. So we basically just need to make one, hopefully last step here. Add the architecture, we'll do it in route, and we'll also do that up here in the synthesis constructor. Okay, now let's see if we can get this running properly. Good. So now we see it says routed via my router. And it's going to come up with an error now because we didn't actually route droplets, and so it's expecting a certain format to be, it's expecting my router to format things properly at the end, and obviously all we did was print out a text string. But it's essentially, it's all in place, and we're calling my router now and my scheduler. Alright, and with that, basically showed you how to insert your new scheduler. The placer, we didn't go explicitly into that, but it's essentially the same as inserting a scheduler. Showed you how to do a new router, showed you the post subproblem compaction router. If you have a different type of router, maybe you're implementing a router that is doing kind of compaction at the same time as computing the routes, then you would probably want to inherit directly from router, just like we did with the scheduler. Also walked you through some of the common errors that might come up when you're inserting, so you kind of know what to expect and know how to handle those. Okay, and with that, I will leave you to create your own implementations.